Welcome to IDSKT. Let's explore an important topic shaping the future of defense and global security. I'm the founder and director of International Defense Security and Technology, a California-based nonprofit think tank dedicated to research and analysis on global defense, security, and emerging technologies. I also serve as CEO of Interplanix LLC, a New Mexico-based company advancing satellite risk analysis, orbital debris forecasting, and space security frameworks to ensure mission assurance and resilience. Previously, I served in leadership roles at India's Defense Research and Development Organization, DRDO. Most recently as Director of the Systems Analysis, Modeling, Safety, and Quality Cluster at DRDO Headquarters, New Delhi. This channel brings you deep insights into the global security ecosystem, from geopolitics and emerging military technologies to cyber, space, and system-level analysis of tech trends and their interrelationships. Subscribe and join us as we decode the forces shaping the future of global defense and human security.
Today, we are diving into the silent but powerful world behind every wireless device you use: RF test equipment. It might not make headlines, but without it, your phone calls wouldn't connect, your smart car wouldn't drive itself, and military radars wouldn't see what's coming. RF test equipment like oscilloscopes, signal generators, and spectrum analyzers are the unsung heroes of the tech world. They're the tools that make sure wireless systems actually work the way they're supposed to, and they're playing an increasingly critical role across industries. Let's start with why this market is heating up. With the global shift to 5G, the RF test equipment market is booming, expected to grow from $2.76 billion in 2023 to even greater heights by 2030. The US market alone is projected to reach nearly $1.9 billion by 2029, with a compound annual growth rate of 8.6%. And it's not just 5G. Smart cities, autonomous vehicles, and the Internet of Things are all driving demand for precise RF validation. So, what kinds of tools are leading the charge? Oscilloscopes are dominating the scene. Engineers rely on them to diagnose waveforms and troubleshoot RF circuits, especially in fields like telecom, automotive, and aerospace. They accounted for over 27% of the market share in 2023, and that number's still climbing. Signal generators are another essential. These tools simulate real-world RF conditions, crucial for testing devices across a wide range of frequencies. In 5G, automotive ADAS, and defense systems, they help engineers build and validate the next general wireless tech. And then there are spectrum analyzers, tools designed to uncover interference, optimize bandwidth, and keep signals clean in our increasingly congested RF environment. With 5G and IoT devices proliferating, spectrum analyzers are growing fast at a projected CAGR of 9.7%. Across industries, the needs are evolving. In telecommunications, RF test equipment is crucial for managing complex 5G systems and maintaining network integrity. In automotive, as vehicles move toward full autonomy, RF tools are used to ensure safe V2X, vehicle-to-everything, communication. Testing these systems is vital for preventing crashes and enabling real-time data exchange. Meanwhile, defense and aerospace applications demand nothing short of perfection. RF test equipment here supports radar, electronic warfare, and satellite communication systems where failure is simply not an option. And don't overlook smart cities and IoT. From smart appliances to industrial sensors, reliable RF testing ensures these connected devices can talk to each other clearly without interference or downtime. Now let's talk trends. The 16 GHz frequency band currently holds the largest share, perfect for Wi-Fi, Bluetooth, and many 5G applications. But it's the 20 GHz mmWave segment that's growing the fastest, as high-speed connectivity demands push into new frequency territory. In terms of form factor, benchtop RF test equipment dominates today thanks to its power and flexibility. But modular systems are catching up, driven by cost efficiency, automation, and smart factory integration. Regionally, Asia-Pacific leads the global market, powered by Telecom rollouts in China, Japan, and South Korea. North America remains a technology hub, especially in defense and aerospace. And Europe is advancing through innovation and strict compliance standards. Of course, no industry grows without its challenges. RF testing remains expensive. High-end gear can cost tens of thousands per unit, and operating these systems requires specialized training. Environmental conditions like rain or fog can also impact performance in radar and satellite applications. On top of that, spectrum crowding and regulation issues are pushing the limits of frequency use. Still, there's good news. AI and machine learning are being integrated into RF test systems, improving precision and lowering operational costs. Automation and cloud-based platforms are making remote testing more feasible than ever before. And who's leading the market? Keysight Technologies, Anritsu, Rohde, Schwarz, and Tektronix are major players, with innovations in every sector. Others like National Instruments, Yokogawa, and XFO continue to shape the space through precision engineering and global reach. Closing scene. Soft music swells slightly. In a world more connected than ever, RF test equipment is what keeps the signal strong. Whether it's beaming data between smart cars, powering 5G towers, or securing the skies, these instruments are the backbone of our wireless future. The RF revolution isn't just coming, it's already here.